So guys, welcome back to our second part in trying to master this concept of calculus. So the second part will be on finding the first derivative using first principles. So grade 12s, you have the formula on your information sheet. So the formula is f prime of x equal the limit as h approaches 0 of fx plus h minus f of x over h. So this part here is the gradient. I think I will choose a day whereby I will prove this thing. Why am I saying it's a gradient? I will choose a day to prove this thing. So now, but we are not there. So I want to show you the idea and what you have to know under first principles. First principle. So now, what in the world is this thing? So we are trying to find the gradient of the tangent at a certain point. So now, how do we do that? We use first principles. So now, grade 12, this is the formula. You'll get it from from your information sheet. So now, we have four curves that we will find the first principle of. We'll find the first derivative of using first principles. So the first one that I want us to look at is the straight line. So number one, I want you to notice something and take note of this thing. So I will highlight here by saying the straight line, which is in the form of y equal mx plus c. So I want us to look at what happens when we find the first derivative of a straight line. So those who did, I know you did derivatives. So when you find the first derivative of a straight line, you get a constant. So now let's look at this thing. Suppose we have f of x equal 2x plus 6. So in bracket here, I'll write it using a different pen. So in bracket, my point is we must be left with h so that it cancel the one in the formula. So now how do you learn math? You learn mathematics by observing, creating connections as you are solving. So now we will find the first derivative of f of x equal to x plus 6. But what we know is along the way, we must be left with h so that this h can cancel the one that is in the formula. So the one that is in the formula is this one. So now let's go ahead and do some problem solving. So now if you look at our formula, which is the first principles, we have f of x plus h. So now that's where we will start. That will be number one. And then if you look at f of x plus h minus f of x, the whole numerator will be our part 2. So now let's get on with it so that you can see the application of on how I find these things. So now I said the first thing that you do, you write your formula. So the formula for first principles is f prime of x equal limit as h goes to 0 of fx plus h minus fx over h. So now where do you get this formula? Is there in your information sheet, so you don't have to memorize it. Grade 12 is there in your information sheet. So now I said the first thing that we will start with is f of x plus h. So now number one, we have f of x plus h. So now what does this thing mean? You see, x plus h has took the position of x. So now that means where we see x here, we are going to substitute x plus h. So now let's go ahead and do that. So we will have 2 into x plus h plus 6. So this is what we will get. Where we see x, we substitute x plus h. So now by distributive law, we will have 2 times x, that's 2x, plus 2 times h, that's 2h, plus 6. So this is our f of x plus h. So now this is our first step. That's where you will get marks. So now the second step, we said instead of finding f of x plus h, we want to find the whole thing. That means we must find f of x plus h minus f of x. So now, what is our f of x plus h? It's in our first step. So this is our f of x plus h. So we have 2x plus 2h plus 6 minus, this is the important part. So we have minus, f of x must be in brackets. Why? Because we have 2 terms that we're going to substitute here. So now we put brackets, then what is our f of x? That's 2x plus 6. So now if you don't put this brackets here, then the answer will be wrong. Because remember, if you are substituting more than one term, you need to put brackets. But if you are substituting one term, we're not going to put any brackets. So now let's use the distributive property to remove the brackets. So we have 2x plus 2h plus 6 minus 2x minus 6. So now what do you notice? When you're using first principles, make sure that certain things cancel. That's the idea behind this thing. Certain things must cancel. So now 2x will cancel with 2x, and then 6 will cancel with 6. Tell me, what are you left with? So you are left with 2h. So now let's go back to the one in red. I said you must be left with h. So what are we left with here? We left with h. It does not matter, the number does not matter, the coefficient, but we are left with h. So now let's go to the formula. The formula is f of prime of x limit as h goes to 0. So now I want us to look at the top part there. The top part is, okay, here it is. The top part, this is our top part. But what's nice is, let me just highlight it like this. That's our top part. But what is interesting is we know that top part, we get it from our second step. So that is f of x plus h minus f of x. And what is the value of the top part? That's 2h. So here we have 2h over h. So now, going back to this thing, we must be left with h so that it cancel the one in the formula. So now if we come here, the h and the h, they are gone. So we are left with limit as h goes to 0 of 2. And what will be the answer for this one? We know that if we have the limit as h goes to 0, this thing is more like, this is our function, which is y equal to, so there it is, as h approaches 0, it's either from the left or to the right, we're still approaching 2. So this is just a horizontal line. Or you can use the idea that says that the limit as h goes to any number which is a of a constant is equal to a constant. So like here, the limit as h goes to 0 of 2, there's nowhere to substitute that 0. So now our f prime of x equal 2.